Hallo. Können mich alle hören? Sehr gut. Yeah, hi everybody, and thanks for joining my talk today about big data analytics with Athena. I'm Wolle. My friends call me Dr. Wingerath, and I did my PhD at the University of Hamburg. This is basically the reason why I said I'm from the university, because my background is kind of twofold here. On the one side, I did a lot of research on real-time databases and related technology, for example, stream processing systems, NoSQL systems, and cloud systems of all kinds. And for 2 years now, I've been working at the software as a service startup backend, where I'm mainly concerned with web caching, big data analytics, and by proxy, aggregation management, which you will be told about later in this talk. So, in principle, I'm a real-time guy because I was concerned with real-time systems for the last 6 years. Last year, I had a talk on real-time processing here at code.talks, where I talked about systems like Storm and Samza and Flink and Spark Streaming. And the gist of the talk was essentially that you need to be aware of all the different trade-offs that are relevant in these kinds of systems when you're developing an application. And the year before that, I was also talking about real-time stuff, but it was real-time databases. So systems like Meteor, RethinkDB, Firebase, and of course backend, because backend's real-time database system is the one I developed in my PhD thesis. So, and these systems work essentially like a normal database. You have users, and you have database, some kind of data storage, and users write stuff and then execute queries, and they get results back. But the spin here is that the database can send you notifications, so updates on what is happening with your query results. And to do that, these systems have to have some kind of process that monitors the write operations that happen on the database. And this is really hard to get scalable and correct. So what we did at backend, and that was basically the gist of that talk, is we pulled that out into a separate system. And then you get a lot of moving parts here, and it really took us a while to get that right. So this is basically the meme we use in Office for that. It's if you have a real-time system, you think you know what should be happening, and then you fiddle around and take 5 years to get it right. And boy, this is taking quite time. Wait for the GIF. Wait for it. Wait for it. Yeah, your Meteor. So, okay, real-time is awesome, but now let's talk about batch analytics. Because I talked about real-time so much, now I'm all into batch. And today's talk will be about our real user monitoring at backend. So we'll start with how we collect data on our users, so in the browser, and then how we write these data items off into storage systems like S3 and MongoDB, and then how we push all that into our data warehouse based on AWS Athena. And the awesome part here is that we have easy to access insights, because we have an SQL interface for all kinds of historical data and fancy aggregations, and then can do reporting with dashboards or basically anything we like. Okay, so let's start with what the data actually is. So what's the domain here? We at backend are essentially concerned with slow websites, and there are 3 main bottlenecks for slow websites today. Just imagine you have a user in Europe sitting in Europe and then accessing a website that is hosted in the US. First thing that happens is the request is sent over the ocean from Europe to the US, and then it reaches the backend, and then there's some processing. And then when the processing is done, then the response is sent back, and this also takes a while because it's a long way. And then the client does some processing, and that also takes a while. What we do, in a nutshell, is we accelerate websites, because the slow request that your browser normally does to get, for example, the HTML, is accelerated by us because we cache your website in our system and then just basically hook into your browser with a process, a service worker, that just decides whether you actually need to go all the way to the slow original backend, or whether you can just replace the slow request, basically rewrite it, and take a faster copy out of the cache. To make sure that the cache is always up to date, we have a real-time synchronization mechanism, and to make sure that stuff like tracking for ads and things still work, we of course do not touch things like third-party resources that shouldn't be cached under any circumstances. If you want to know more about the underlying technology, so service workers, I highly recommend Eric's hackathon tomorrow at 16 o'clock. It'll be awesome, and it'll be in Kino 7. Yeah, anyways, the special part here is not that we do caching, but that we can cache basically anything. For example, we also accelerate personalized HTML files. And the idea here is that we cache the anonymous portion of a website. So for example, the page that you see when you are anonymous and not logged in. And then we get that fast out of the cache and display it very, like in a second or what. And the original, the personalized website where you have your name and your recommended products and stuff like that is fetched concurrently. And when it arrives, we just patch the personalized info into the anonymous website. So you get a very fast anonymous website, and then things like the number of items in your cart just pop up a second later or so. And the effects are very significant. We really speed up the websites by a huge amount. And the question that our customers have, because they pay us to do that, is, okay, what do I gain by using your service? And we evaluate this for them by doing split testing. So we have users that use SpeedKit, their SpeedKit is enabled and is making the website faster, and then we have users without acceleration. And we collect tracking data from both these user groups and then do a comparison and compute and measure the uplift. So performance, user engagement, and business success. And this is quite complex, and basically everybody agrees that page speed brings money, but it's hard to say how much. And just as another advertisement for our talks, tomorrow, Friday 11 a.m., Felix is going to tell you all about the awesome study we are currently doing with Google backend and the University of Hamburg to find out what exactly web performance brings in terms of business uplift. Yeah, anyways, we are doing split testing, and to do reasonably insightful speed testing and A/B testing, we need all kinds of metrics. So we need performance metrics like the time to first byte and the first input, when did users click something. We need user engagement data like the session length, or we need to collect information on bounces. And of course, business data, for example, how much revenue is generated with users, and how many items do they put into their carts and stuff like that. And of course, we need debugging things. For example, we often see unhandled JavaScript exceptions in the websites of our customers, and we can tell them about it and make their shop better and faster just by removing existing problems there. Yeah, the difficulty is these kinds of information are not that easy to collect. And the first idea that you might have is, okay, let's just log everything that we have on the backend side, so on the servers and stuff. But the problem is that's not enough, for example, because you wouldn't know anything about user behavior or rendering performance, or when was the page load actually finished and things like that. But apart from that, it's difficult because we only see a small portion of all requests. So for one thing, we wouldn't see browser cache hits, and we have lots of them because browser caching is basically our shtick. We do very many things to accelerate websites based on browser caching because we are doing much research on how to use the browser cache without exposing stale data. And even origin requests, I mean, there might be logs somewhere, but these are the service of our customers, so we don't have access to them. So we can't really tell you anything about origin requests either. So if we're only collecting logs, we only have the CDN, and that's not much. I mean, we write it off to S3 and then analyze that, but we need additional info, and we get additional info by our own page impression tracking. So for every page load that a website visitor of a SpeedKit accelerated website does, we send a data beacon to one of our application servers and then write that information off to MongoDB. Yeah, so I told you what we collect and how we collect it in a nutshell, but the question is, when do you actually send such a data beacon? Because you collect all kinds of information and you have to basically wait for the right moment to send the information. So when you load a page, the first thing that happens is, yeah, somebody clicks something, the user clicks, and then the click is detected. And at that point, essentially, several pieces of information are already fixed. for example, the URL or the user agent and the session ID, the user ID. You can't really send it at that point. You have to wait a little until the processing phase of the page load, but it's fixed already at that point. Then the loading starts, so we have connection establishment and the request is sent and the response arrives, and then we have some processing and stuff. And finally the load event is triggered, and then the page is loaded and the browser says, okay, I'm done here. But even after that, you can still have user input, for example. And you don't really know anything, when it occurs or how many inputs you'll get. So what you essentially have is 3 different kinds of data beacons here. The first one is for static info like the URL, the user agent, session ID, etc. The other one is for timing information, so how long did you load, when did you receive the first byte, when was the first paint. And the third one, or the third kind of data beacon, is for everything else. So for when the first input occurred, or when something was put into the shopping cart, or whatever. Okay, these are essentially the beacons, and we in our system consolidate the first 2 types of beacons into the so-called metric beacon. So this is the one with the technical info, and then we have custom event beacons for custom stuff. Okay, so now you know how our data collection works on a high level and how it looked when we started analyzing that stuff. And now I'm going to explain what we did and why we think it didn't really work, and what we are doing now and how it works. So the basic setup here for our tracking data in Mongo is we have one collection which is called metric, with the metric beacon stuff, and then one collection with custom events. And the custom event has a foreign key to the metric collection, and this way you can just join your stuff together and have all information on a certain page load. So if we are debugging things, for example, we are surfing on a customer website or in staging environment or whatever, we can just check out our own session ID and then basically inspect our own session at the moment. And if we need more high-level information, we can aggregate things, for example, compute average session length, or something like uplift versus acceleration by using the aggregation pipeline. So for example, we can say speedkit versus no speedkit users, what was the uplift in terms of performance and how did that correlate to the conversion rate? So was there an uplift, how much was it? That works okay. And the CDN logs also have to be analyzed, and that's a bit more difficult because the CDN logs are essentially just gzipped and then dumped to S3. And then we're having basically log files that are zipped. And to analyze them, we needed to download them and do some kind of ETL, which we made with custom ETL logic at first, so that we could dump that into PostgreSQL. And then we ran all kinds of analyses on that and generated output CSVs with which we could feed our diagram software, to make fancy diagrams. That went nicely at first. We automated that via Jenkins and had every morning a new report on the customer. That was pretty cool. And what we gained from there was essentially caching-related insights. So something like efficiency of our image optimization, or something like a distribution of request latency. So that was the big picture, and this was how we thought it would be, and it was at first, but there were several problems. The first problem, one of the problems was that CDN data import wasn't as easy as we thought it would be. So the first problem here is that every CDN node in our architecture may potentially serve requests from any website that we are accelerating. And this means that since we can only export logs partitioned by time, that S3 stores our data only partitioned by time. And if we want to inspect one particular customer, we have to download all the log data for this particular hour, filter out all the stuff we don't want, and then only use the customer we were actually trying to analyze. And this doesn't scale with customers, because if you have more customers, then you always have to download and extract and parse more data. And the next problem was that we had to import stuff into PostgreSQL. And if you are having really, really much data, this is really, really difficult. And the thing was that we grew into a situation where we had queries that wouldn't run at all without indexes, but we couldn't really import any, gigabytes worth of data into an index collection because that would take too long. And we could drop the indexes and import, and that was quick, but rebuilding would also take too long. And the query without index wasn't feasible in the first place, so that didn't work either. And looking at Mongo, we also had problems because you can't just execute an aggregation pipeline query on a production MongoDB database without indexing anything. So you always have to really carefully design your queries and index things that are relevant, and that was just a huge hassle if you're trying to explore data. Plus, even if it's indexed, it's still pretty slow because the aggregation pipeline doesn't really scale well. And another issue here, the scalability was an issue. And another issue was that aggregation pipeline queries are relatively complex. So we thought it wouldn't be so bad because we thought, okay, we're starting, and you do that for a year, and eventually you'll know what you are interested in, and then you'll have your few queries and optimize them, and that's that. But it doesn't really go like that. You have to explore data all the time, and MongoDB isn't really the best tool to explore data. So we were not really satisfied with using MongoDB, and we also weren't satisfied with the reporting that we had, because our architecture from above looked like this, Browsers are requesting data from CDNs. We have logs from the CDN. They go into S3, and from there into our ETL logic. And the other way around, we had PI tracking data hitting our application servers, being written to MongoDB, and from MongoDB we could also access the PI data in our ETL logic. And the idea was that we could just run our Jenkins jobs or whatever, and then have automated reporting and nice diagrams, and everybody's happy. But actually, it wasn't just simple ETL code. We had to load data into local MongoDB replicas so that we wouldn't hit the production cluster, because that was getting so much load from the aggregation queries that we didn't think it was a good idea. So we said, okay, let's go to a local replica. And extracting S3 data is also you download the stuff and then you extract it from the gzip file, and then you parse it, and then you have to filter things out, and then you have to import that into PostgreSQL, and then you have to run your analysis, and then you have to generate output, and then you can generate your diagram. That's just taking, that's a lot of hassle there. And in the end, it was usually you do something and something doesn't work, and then you have to get your developer and look at it, and it just takes time. It wasn't really nice, you had many problems. And the thing that really made us rage quit the entire architecture was essentially joins in MongoDB. Because, it's humongous, it's in the name, and you think, okay, probably this is going to work. No, update, it's not going to work. Queries on individual collections, that might be all right, but if you start joining things, then it's just agonizingly slow. And we had beefy servers working RAM only, it just doesn't make a difference. It's slow. And the problem was that our conversion tracking relies on custom events, because you can't just go over information like timings and the URL. You need things that are essentially only available at a future point in time, and we can only track them via custom events. And that means that we have to do this join between the custom event collection and the metrics collection. And this didn't work, and so we couldn't really analyze the conversion rate for big customers. So we could do it, but it would just take agonizingly long. So the end result was, okay, MongoDB and aggregations doesn't really work. So what did we do? Spoiler, we used Athena. So in essence, we were getting so desperate that we thought, okay, let's just dump the MongoDB collection, let's upload it to S3, and then just try it with Athena. And this is just an example. A typical analysis would be something like, okay, we have this single join, and then we would just say, okay, we have like 3 million PIs. Depending on the customer, this could be a week, or it could be like an afternoon worth of data. And we knew that there would be a time where we would have to analyze like 30 million PIs, and it couldn't take like an hour. And this little analysis here already took like 15 minutes plus. And then we just slapped Athena onto the problem, and it just, the runtime just dropped to 10 seconds or so. And this made us essentially realize that this desperate attempt was in fact the new best practice for us. Yeah, and Athena, just because the talk has Athena in the title, I thought I might add a slide on Athena. It's a managed Presto DB. So Presto is a SQL distributed SQL engine developed by Facebook for like really petabyte scale style, really big data volumes, and it works with all kinds of data stores, so you can consume data from S3 or MongoDB or whatever. And its pricing is pretty simple because you just pay for the scanned data. So you can, it's pretty okay pricing because you can have complex queries that run for a while and they are very cheap, but you just have to watch something like stuff like efficient storage, or you have to use partitioning and be a little careful with your query design because scanning works extremely fast and you just burn money if you file the wrong query. Anyways, Athena is pretty awesome, and we replaced basically the entire custom code and reporting stuff down there in our architecture and said, okay, let's put MongoDB data also to S3 and just hook everything into Athena. And then we'll do the reporting behind Athena because like this, we could just use SQL for the reporting part. The big advantage here was that everything got way simpler because all the data was now in one place, and that was really helpful. And it was easy to access because everybody speaks SQL. And further, we have a more scalable and efficient system here because Athena really scans like hundreds of gigabytes in seconds, and also has, if you're not like using very complicated queries, response time on the order of seconds or minutes. Yeah, but an important thing here to note is that depending on what you do, you might have something like an alerting system, or you want simple statistics like, okay, how many users are on my website right now or in the last hour or something. That is really easy, and then you have sometimes analysis like trend analysis. You want to know, okay, was my POC successful or not? And then you are looking at weeks worth of data. And depending on what kind of analysis you are doing, the latency that you are willing to accept, or that is reasonable, or the time span that you are looking at grows. So our processing is organized in stages, and the later stages just take longer time. And in the following, I'd like to explain you what the stages are in general, so that you get an idea of what the analysis steps here involve. So the first step is essentially step 0, and it is just data preparation, because you put the data into Athena, meaning you just dump MongoDB collections in there, and that's really the process. So we don't do anything apart dumping, gzipping, and uploading. So what you get is data that looks like the thing on the left there. It's a pretty ugly JSON. And what you want is something like this, so a table with timestamps in it. And to get that, you have to do two things. First, you have to create a table schema so that Athena knows what kind of data is sitting there. And then you have to create views on top, so to hide artifacts. So for example, to convert the ugly JSON representation of a timestamp to the to a normal SQL timestamp. And just to illustrate this process, and that's awesome that it works at all, but that is also pretty annoying to do that, I thought I'd show you how we transform timestamps, for example, from MongoDB dump to Athena format. So this here is the attribute load event end raw, so the load event end as a long number, so a Unix timestamp. And if you just select that, you'll get some ugly JSON representation, but we want a timestamp. So what we have to do here is first, we have to just extract the long value, which is now a JSON, so we also have to cast that to a varchar and then to a decimal, so that Athena knows, okay, this is now a number, and since we know it's a Unix timestamp, it's a number of milliseconds. And Unix timestamps in Athena are also like the number of milliseconds until now, but the thing is, Athena encodes that as seconds. No idea why, but that's the case. So you also have to divide that by 1000. And then you can already say, okay, this is a Unix timestamp, please convert it. So this would be, give me a timestamp from this number, but of course you know that browsers sometimes just send you crap, and you also have to filter out said crap. So what you have to do when you want to filter out rubbish is essentially wrap a case when statement around that, and then you have like 26 lines of code for a single attribute. And you do that for all the attributes, and then you end up with a very, very nice table, although you have to keep in mind this is still a timestamp. So if you want something like 1,000 milliseconds because the load event took 1,000 milliseconds, then you still have to subtract something like navigation start there. Okay, then you have prepared your data, and then you have tables, and you can do stuff with them. And we still have, in our case, the metric and the custom event tables separated, but we would like to have them in a single table so that we have one line, one row in the database for every page load. So what we do is we join them together, and in the process we also do cleaning. So for example, we nullify the load event when it takes place before the navigation start, because then obviously something is broken there. And this happens, for browsers especially. The next step would be that we also just resolve user agents. So the strings at the bottom are typical user agents, and they are just hard to interpret for a human, also hard to read and hard to query. So we take a service that basically stores many user agents and maps them to operating systems and browsers and so on. And just in case, we have a simple fallback rule so that we have some remotely reasonable values for user agents that we cannot resolve in the service. But they are really esoteric, so it doesn't happen that often. But the thing is, we have really, really many combinations of operating systems and browsers and whatnot. And therefore, we also have to do some kind of simplification here. Because if we want, for example, statistics by browser and by operating system, you're probably thinking of things like, okay, mobile, desktop, tablet, that's a device, and browser would be Chrome, Firefox, and the likes. But there are also things like, for example, wearables or vehicles, and Tesla has a browser, and if we list all those in our statistics, then you just can't see anything. So you also have to think about that. And then it's getting interesting now, because now we're entering the territory of session metrics. Because at this point, we essentially have one table where every line represents a page load with all the information we would possibly want to know. And now we are aggregating things by session ID to compute things like, for example, the session length, or was this session a bounce, Did they leave immediately, or did they click around, and how long did they stay on the site, or what was their performance? So for example, the median first contentful paint. And things like that are important because, for example, you want to correlate, okay, are the users with better performance the ones that buy more, or maybe is it correlated to the operating system, or to the device model, or to the browser version, or to whatever. And as illustrated at the top there, you can see that the individual PIs are in this time scale there, and then essentially a session timer runs out, and if the user doesn't do anything for a while, then a new session is starting for the next PI. So in this example, we have a visit on the landing page first, and then while nothing happens, so session 1 ends, and then in the next session, red user clicked, and then blue user clicked, and then the checkout is clicked, and something is bought. And then maybe the guy just, turns off the notebook and then pops it up later again and starts surfing again. But it's important here that you notice the first visit of the checkout page was the actual conversion where something was bought, and the second one might look the same, but it's a duplicate, and therefore you have to do also deduplication, which is pretty complex if you're doing it with huge amounts of data. And then essentially we also have the fourth step, which I'm not going to detail here, where we aggregate things over weeks and just have big batch jobs for the protocol that was not intentional. To do stuff and to compute things like business success over the proof of concept phase, did we produce an uplift over the last 3 weeks or things like that. So to wrap it up, this was essentially the analytics part, where we started with custom crap, I want to say, and went to a unified analytics solution, namely Athena in our case. But at the bottom, we still have mayhem with reporting, so we thought, okay, which would be the ideal tool? we would like automation, easy data exploration, because that was pretty annoying with our solution, and a robust tool would be nice. So obviously we went for QuickSight, and the reasons were threefold. First, it was easily integrated with Athena because it's an AWS service, and we just thought, okay, they offer it to you, it's everything from AWS. It must be awesome. The next thing is it's pretty easy to use, so we tried it out, and you click around and you think, wow, this is nice. Awesome tool. You just things happen, and it's very quick. Also, it's also in the name, and we thought it would be the tool for us. And this is essentially where the serious part of the talk ends, and I'm talking about real-world experiences with QuickSight and Athena, because it wasn't as awesome as we expected it to be. One example just to illustrate the kind of frustration you experience when you're working with QuickSight. You click dashboards together. I mean, that's basically the point of this tool, because it's a reporting tool. And this is an example dashboard. We don't have any numbers because we don't want to show numbers from our customers. But this is how it looked. And then you have like this white space on the right, and think, okay, maybe I could just resize my browser because all this space is just wasted. And then you do that, and if you notice at the bottom, this gray area just starts growing, and you don't really know what to do. You click around, and then flat. Yeah, now you click, but you can click all you want and resize. That thing is gone. So what you have to do is reload. And I mean, think about it. You have this tool built for reporting. You click a dashboard. You just try out the dashboard, and the first thing that happens is that. You don't want to show that to your customers because they think you're idiots. Because hello, it's a dashboard. What on earth is happening there? But maybe this is just us, because there are other things in the AWS dashboard that behave similarly, where you think, okay, this is kind of strange. For example, time. When you execute a query, or let's start differently. When you think about time, this is basically how you would expect time to behave. You have a 0 and then 1 seconds, 2 seconds, 3 seconds. And if you execute a query, then you would expect, okay, probably the execution time works something like this. But Athena says something like, okay, I'm executing a query. I'm estimating the time it took so far. Let me guess. I'd say roughly 0 seconds. And it says that for like forever, because this is Athena time in the dashboard. And then it says, okay, wow, that was quick, dude, 2 seconds, awesome. And this is pretty annoying because you're waiting for things to happen and you don't really know, okay, am I waiting for an error, or am I waiting for like what is happening here? And this is, this is just annoying because it's dashboarding issues. If you integrate QuickSight with Athena, then you get like problems of a completely new quality. So imagine that you have QuickSight and you have dashboards, and these dashboards work on top of data sets. And these data sets in turn are essentially stored in Spice, which is QuickSight's underlying data store. And it is fed from the data store that you connected to. So for example, Athena in our case. So if you change something in your schema in Athena, you might want to edit or refresh your data set, and then you have to click the edit button. So you click the edit button. And Athena, just says, okay, I'm loading a preview here. And you go like, this is strange because the overview panel said the import was complete. So if it's just a preview and I want to edit things, why don't you just give me the 53.6 kilobyte that we already have? No, it loads. Okay, so you wait, and eventually it says, something went wrong. Okay, this is interesting. I wish I had any kind of info or indication what went wrong. Like, no, but you may reload, I'm a buddy, just click the button. And you click the button and you pay for every single time, but nothing happens because something went wrong. And eventually you go like, okay, let's watch the Athena history. And this would be, it's a talk of its own. Really, this history interface is strange, but you cram up, you fill out this entry and see, okay, the query, let's look at it. And you just, okay, it succeeded. First thing to note, it succeeded. And the second thing is, it scanned 43 gigabytes. And now you think, okay, I mean, I already had 53 kilobytes preview. Now we loaded 43 gigabytes. I clicked 5 times, and it succeeded. And the reason why it failed is, of course, there's a 50-second timeout in QuickSight for whatever reason. And if your query takes longer, so for example, the preview query, then it just fails, and it doesn't tell you anything apart from, yeah, went wrong. Yeah. And then you say, okay, well, okay, maybe I just ignore the preview from here on. I just pay twice because I click edit and then it just fires up the query. Let's just not think about it. But this time you still didn't edit anything. You just paid 5 queries because you reloaded the preview, and then that was that. And things like this happen all the time, and it's pretty annoying. And there are more. Like, the questionable limits are one thing, but if you're working with Athena, even not with the dashboards, but with, you know, like, SDKs or anything, if you're working during the day, then your things fail all the time because resource limits or resource usage are essentially a different thing during day or during night, and that's very annoying because you just repeat things and then they work. And another thing, I think it's my favorite, is that QuickSight just rewrites your query but doesn't tell you. So for example, if you say select everything from table blah, then QuickSight won't execute that, but it will rewrite the thing, it will roll out the attributes. And if you change the table, then QuickSight won't notice because it already rolled out the query, so it cached that. And the asterisk in your query is still shown, but it doesn't mean that it selects all the attributes. You know, you have to know that, and then you have to rename things and save and refresh again so that QuickSight notices that something changed. And this reverse engineering of the reporting tool was hugely annoying, so we're not really sure whether we will keep this one. Okay, this is essentially my talk, so the last slide now is the outlook, because we're still talking about batchland, and I'm a real-time boy, so I would like to return to my home country. And we are pretty hyped about Kinesis and Kafka, so we'll probably in the sense that it's in the next sprint. Yeah, start pushing our data not to S3 but to Kinesis. And the goal is basically that we have continuous ingestion and also continuous analytics to gain real-time dashboards. And then we'll also drop QuickSight in the process because, dude, it's just not worth it. Yeah, we think that this is going to be awesome because our customers will have real-time insights into their data, and we will have as well. So this will make the world a better place, essentially. And I'm very happy about the prospect of this endeavor. So thank you for your attention. Hello. As a very last note, please let me state that tomorrow there will be 2 awesome talks. One is Felix's web performance study talk, and the other one is Eric's service worker hackathon. It's a blast. I listened to it last night. And today at 16 o'clock, which is essentially right here, right now, we'll have a GDPR panel discussion, and I'm sad to participate. I'm very excited about that as well, so please come and watch me fail. Yeah, thanks.